Hello, I'm Tom Griffin, CEO of Catalyst Unity Solutions. Welcome to another episode of Tech Talk with Tom Griffin, where we meet with the key players from leading electronic manufacturers to discuss their latest successes, design challenges, and insights for our industry. Today, I'm pleased to introduce J.D. Johnson, Executive Vice President of Business Development at PowerSonic, is here to speak with us today about lithium batteries. PowerSonic, a 50-year-old global manufacturer of various battery technologies with the broadest offering of battery technologies in the industry. JD will be speaking with us today about an interesting success story in switching a customer from AGM batteries to lithium batteries. JD, why don't you start off by telling us a little bit about the application?
Sure, Tom. Thanks for the opportunity. The customer is Radar Sign located in Marietta, Georgia. And their application is a mobile roadside sign used for speed control. And specifically, their models use solar energy to power the unit and our batteries as an energy storage for a reliable backup power source. The customer has been using a very good traditional 12-volt, 18-amp-hour lead-acid battery. And after discussing the benefits of lithium, they moved to a much better battery for their application, the PSL BTP 12200. It's a 12.8 volt, 20 amp hour lithium battery with Bluetooth capability.
Oh, so tell me more about the PSL BTP 12200 battery. What makes it better than an equivalent SLA?
Well, first, the most important is the chemistry. It's a lithium iron phosphate battery, one of the safest lithium chemistries manufactured today. And with this type of lithium chemistry comes a myriad of significant benefits over the standard SLA battery, including 5 to 10 times the cycle life, double the power density, 1/3 the weight, lower internal resistance, and twice as fast at charging and recovering, lower self-discharge, Bluetooth communication capability, and overall a better battery technology. Another benefit with this battery is a direct drop-in replacement for the battery that they're using, meaning they don't need to change any of the sign to accommodate the new technology.
So I can imagine in this roadside radar sign application how cycle life would be a huge consideration. But did I hear you correct? The lithium battery really provides 5 to 10 times more cycle life than the SLA battery they were using?
Yes, it really does. And when you compare the cost per cycle or return on investment, ROI, between each chemistry, lithium becomes a more economic option as you'll have to replace it less often than you would with an SLA battery, especially in a cyclic application like this. It was one of the top reasons why the customer made the switch. But lithium also has other benefits that make it a more attractive option.
So I'm interested in this 2x charging capability or recovery. How is this important in an application like this?
Great question. We're all familiar with the requirement to charge a battery, but not everyone understands the physics involved. We have a full white paper on our website, and if anyone wants to look at the full technical description, they can find it there. In brief, the traditional lead-acid battery has a very specific charge method to complete the charge to the battery to reach 100%. In the last charging stage, you go into a float or a trickle charge. While most of us have heard these terms, not everyone understands this is a requirement to overcome the internal resistance of the battery chemistry. And at this stage, it's very important to the overall health of the battery. In essence, the float charge is slowly charging the battery to 100%, and it takes a long time to do it. With our lithium batteries, there's very little internal resistance, which allows the battery to charge much quicker, and more importantly, allows the product to be back into full service.
Wow, that's amazing. So you also mentioned power density, lighter weight, and lower self-discharge. How might these benefits come into play in the application?
Well, the power density and the lighter weight makes a great combination. The power density is twice that of an SLA battery because the lithium battery is so much lighter. In an application like this, where the installation may be difficult, it is very important to cut the weight where you can. The easy handling of a battery was of great benefit to Radar Sign. Also, the lower self-discharge in the lithium battery means that means it doesn't need to be at full charge nearly as often as the SLA battery. In fact, the lithium battery can go 12 months without being charged, with only losing 3% of its capacity, whereas in an SLA battery, you lose about 20% of the capacity in just 3 to 4 months through self-discharge.
Wow. Those are amazing benefits of the lithium over SLA. So I can see why Radar Sign chose the lithium solution, but you also mentioned the drop-in replacement aspect. Can you elaborate on this a little more?
Yes, glad to. In an OEM application like this, size is everything, because the application or manufacturer often has a set size already designated for the battery, and picking a battery that has widely different dimensions could cause the adoption of the new chemistry or dimensional issues elsewhere in the application. While we can design a lithium battery to fit in approximately half the space of a traditional SLA battery of the same voltage and capacity, we have designed many of our off-the-shelf lithium batteries into traditional BCI group sizes, especially in our series-capable lithium line, where we can offer 5 group sizes over a range of amp hours. This really makes the lithium battery a direct drop-in replacement for the SLA equivalent.
Wow. Thank you for that. So, okay, one last question. I think I may have saved the best for last. So seriously, Bluetooth communication capability in a battery? Are you kidding me?
Yeah, seriously. We have a full series of lithium smart battery technologies, which allows the user with a smartphone, either iPhone or Android, to check the status and health of the battery. These PowerSonic batteries come with a free Bluetooth downloadable app, enabling the user to quickly locate all of the PowerSonic Bluetooth batteries within 120 feet or approximately 30 meters without the need of internet or cell phone coverage. The specially designed app easily manages the state of charge, voltage, number of cycles, internal temperature, capacity, and overall health of the battery. It also records any detrimental conditions to the health of the battery on the event log, provides quick reorder information, and more importantly, provides the confidence the battery is going to work when they need it. Customers will no longer have to spend hundreds on test equipment, remove the battery from the application to check its status, or find an engineer or technician to find out the state of health or state of charge of the battery. With this app, you can now check a smart battery in a matter of seconds. It's like having a 10-year battery expert and $2,000 of expensive electronic equipment in your pocket, all from the comfort of your cell phone.
Wow. Well, thank you, JD, for that great explanation of this application. And thank you for watching this episode of Tech Talk with Tom Griffin. See you next time.